Well, good morning, everybody. All right, it's Friday the 13th, and as we think through where this forecast is going to be taking us, there's a couple things I just want to bring up here. We're in this very important time period as we get into the second half of the month of June, where we start to see the beginnings of the summer pattern setup. And a lot of the discussion is going to be about those big subtropical highs. I've been making a big deal about it. There's a reason for that. I mean, doing this for a long time, you start to just pay attention to those features and understand that they can really have a major control on the summer weather pattern. So we're going to dig into that again today, but I'm going to do something a little different here. I'm going to use someone else's analog years to kind of help me guide the process because Phil Klotzbach, who is at Colorado State University, absolutely brilliant scientist, been doing this work for a number of years. He does hurricane season predictions, and he's widely accepted as one of the best in the business to do that. And he just released an update earlier this week, and we're going to use that to try to assess a few things. But I've got other big questions we're going to try to answer in this forecast video, which is where are we starting to see some of the precipitation turn on and turn off across the United States? So let's get there. Okay, you've been watching an animation here of satellite data just going back to yesterday, and just as I pause here as the sun was setting, we had another day. Let's go look at this. Look at the intense convection that was over the southeast. Keep that in mind. It's been very wet here as of late. Large storms that move through parts of the southern tier of the United States to the Delta, lower Mississippi Valley, some of them producing locally very heavy rainfall. Storms kind of popping along as we saw in the forecast models here, the higher elevations getting up toward the Rocky Mountains. We're going to continue to watch this area for the next several days. It's going to be a source region for bigger storms. And then there's a low coming out of Texas moving its way toward my home state of Illinois, where we're expecting quite a bit of rainfall out of this. That one storm right there was one to watch last night on the kind of South Dakota-Nebraska border. It was a hailmaker, big-time storm system rolling through there. But if you just rewind the clock a few days and look at the last 72 hours of total accumulated precip, there's some important things to see here. Locally, the rainfall amounts in the southeast were very large. Some of the storms putting down 2, 3, 4 inches of rain. Same thing for the kind of the very lower Mississippi River basin here. There's been some heavy rains even this morning coming through this region. You've probably seen some of the videos of the flooding like in San Antonio, pockets of incredibly heavy rain. And to the north, early this week we had hail, we had straight line wind damage that came through this part of Iowa, southern Minnesota. And again, last night we just saw the large hail producing storm that was right in through here. Scattered rain throughout Montana, very welcome. We need to get this moisture back into place. Montana's been a key state to continue to monitor for drought pressures as we go forward here. But I just want to zone in here on an area I want to focus on today. So I was on the phone last night with several of my colleagues that work for Nutrien right in through this area. And you know that throughout this spring season, I've confessed almost that this was an area we missed, right? We thought that most of the heaviest of the precipitation was going to stay, in the mid-south of the Ohio Valley. We were expecting, very wet, tight windows in this region. And then about the time we got to mid-April, that whole narrative began to shift. And the Red River Valley came into play. And more of the storms made their way back into, parts of Texas's panhandle. Now, I want to show you where I'm concerned over the coming days and weeks. And it's going to be in this area. And some of the reason for that is just take a look at our 2-week weather forecast models. So I'm going to show you 3 maps. They're going to come from the European model, the artificial intelligence, and then the GFS ensemble. And they're going to just look at the next 2 weeks, which gets us, to June 27th. And what we're going to take note of here is, all right, we've got some drier conditions here. That's indicative of maybe where higher pressure is going to be, which means we're likely going to be pumping in moisture around the Bermuda high. We are expecting troughs here, but ridging there, which means ridge-running thunderstorms that are going to come through this area. But something's going on here. And if you take note, that very, very dry outlook in this region, well, for the last 2 months, we've been very, very wet in this area. And something's going on down here we've got to talk about as well. Okay, that's the European ensemble. There's the artificial intelligence. And here is the GFS. And you start to see a similar pattern. Look at them real quick. And with that kind of agreement, we begin to look for the pattern causing this in the models and then ask ourselves a question, is this consistent with our thought process going into summer? And how long is it going to last? That's going to be what we're going to think through. Now, all of that wet weather that's coming out of, if you just go back to it, let's just look at this down here. All right, what's going on down here in parts of Mexico, Central America, the Caribbean? Matt talked about it earlier this week as the Caribbean gyre. And what's happened here is that lately we've just taken the lid off of that. There's been this progression of the MJO. We've talked about it for a few weeks. and it's about done. But right now, the best rising motion in the tropics is kind of centered on two spots. One is here in Central America, Northern South America, and then Mexico. And the other area is right over here in India, just south of India, almost just to the east of Sri Lanka. And in the middle, we have a large area of subsidence in the atmosphere. And we don't expect it to stay like this long. This is going to rapidly transition and begin to move. But as we think about it right now, what is this indicating for us? Because there is some pretty intense tropical convection that's going on here. And you can see it in this satellite animation here from Tropical Tidbits. And we know that from the National Hurricane Center, we are watching. In fact, let's get an update on this, see if anything changed or didn't. But we are going to be watching for the next tropical cyclone to form. It's currently called Potential Tropical Cyclone 4E. And we do note that here over the next few days, getting out there into the weekend and out to Tuesday, this is going to strengthen to a tropical storm, getting its next name, which is, I believe it's Delalia. I'll have to go look that up. I apologize, but it'll get that name. And again, it's not expected to turn into Mexico, but is going to be moving what we think out into the open East Pacific Ocean here. Now, because of that, we just went back and looked. I'm just curious if anything else is expected to form. And if you just run out the European model on its prediction over the next 10 days of where we could have tropical depression development, we've got this depression here, potential tropical cyclone 4 showing up, but there's also some stuff going on here. And this is partly the reason why you saw, let's just go way back and find it again, why we see such, wet conditions that are coming up through this east coast of Mexico getting into southern Texas. Now, that's not to ignore the rest of the country, but that just had me thinking about a few things, knowing that Phil just released his new forecast. And here it is. Okay, so what did they really change? Not too much. Overall, there's still this prediction of an above-average hurricane season, but he's very careful in the way that he talks about this hurricane season, especially from the difference between this and a year ago. And I highly recommend that you go to this and read it if you're curious. It's a very, very good read. What I want you to do is just come here, look at the stats. Okay, all of these stats are different ways by which we measure the hurricane season, and then click on this right here, his forecast press release. It's a very good way to look, or just read the summary below, but you can get some really solid information out of what Phil is thinking. Now, as I read it, I was mostly curious about how he's looking at very specific analog years. And those analog years are listed right here. So I went out and I looked at the years 96, 99, 08, 11, and 21. Those are the years that he chose, that he says these are our closest analogs. And Phil is very good about this. He's saying none of these are a perfect match. But if I had to choose a grouping of years based off of certain atmospheric things, sea surface temperatures, pressure patterns, MJO movement, those kind of things, those years start to fit the bill. Like, for example, if you take a look, cooler weather, across the Gulf Coast, these are cooler water temperatures. And there's our dead and decaying La Nina and the warmth that's here in north of Hawaii. Notice that the Atlantic is not overly warm in those years either for June and July. And if we just get in there and have a look at the current ocean temperatures, and I found this to be a much more instructive map by looking at today's difference in ocean temperatures compared to the global average, not the historical average. And we start to see these differences showing up better. So there it is. You can see the cooler water here, the very warm water that's come out of the West Pacific warm pool into and north of Hawaii. And we start to see the differences in the temperatures across a lot of the Atlantic. And this is critical. A year ago, this was 2 to 3 degrees Celsius warmer than it is right now. But looking at all of those years, I wanted to start to dissect a few things. Okay, precipitation-wise, let me shrink that up again. This is what May of 96, 99, 08, 11, and 12, and 21 looked like. Those are, again, his analog years. And we start to look at that and go, wait a minute, we've not been anywhere near that this May, right? I mean, this May has been wet here. Has been very dry in Florida, but it's been very wet here. We were wet here, and we were wet there, and wet into the Northeast. And we were drier at times in May in parts of Western Corn Belt. So first kind of strike against using this is like we're not noticing that May's precipitation patterns in these analog years lines up with what this May has given us. So these are not the end-all, be-all perfect analogs. If we flip this over to, let's leave it there, but let's go to temperature. All right, same year as May. Create the plot. Those Mays, there's something a little bit more similar to this, right? We were hot south, and we've been cool in this area. So maybe there is some correlation there, but the precipitation patterns this May have been much more, large in their ranges where they delivered moisture. So, okay, we understand Phil's ideas behind this, but I want to think harder about where this is going to go. So I made a couple of other maps I want you to examine. As we work through June and July, for his analog years, let's come back to something I've been harping on. Take note of where the subtropical high pressure cells are, the Pacific high and the Bermuda high. Now take note that they're not anchored here or there in those analog years. Now each individual year had a little bit different position, so this is a composite of all of it. We're just looking for some sort of similarities. Take note of the strength of this high that's coming off of Siberia or the one that's north of the Black Sea. Those are very important positions for these high pressure cells. And we're going to talk about this. And then let's take a look at another map. This is when you come down to the surface and look at where the pressure patterns are, just above the surface. And I take note of a few different high pressure cells, one here, one there, and one there. Now that means that, if we just focus on the Bermuda high, this would represent a Bermuda high that's more of an Azores high, maybe more spread out, not as intense. Meaning that when you keep this tucked in here and keep it really, 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 really strong, we tend to get stuff that just sneaks off of Africa, grabs hold of this, and just comes ripping into the midsection of the Gulf and then right into the Gulf Coast states, and it just goes. But if it's more strengthened, a bit north and to the east, that's going to change the way that these tropical systems form. And you can see evidence of that. So I went out and recreated for all of those years in his list where the tropical cyclone tracks were. And if you just have an idea on this, if we place our higher pressure here, you start to see that more of these systems are making this turn out in the open ocean. All right. Now that's a common thing anyway, but it'd be much different if that high pressure cell was centered here, shoving all of these tracks further to the west, right? That's just one very simple idea behind this. The other thing we get concerned about, and I was talking with Matt and Andrew about this yesterday, is that if we do end up placing high pressure more in this region, I mean, you're pulling very dry subtropical air from this area, and it tends to shove it into this particular part of the hurricane main development region, meaning that these hurricanes tend to chew on a whole lot more dry air that's coming out of this. I mean, this is a very dry part of the North Atlantic. And so that gets us just thinking, are we going to see maybe a lot of tropical cyclones that skirt the United States because of the positional movement of the Bermuda High? And are they going to be eating too much dry air, meaning that they may not be as strong? I mean, those are all really valid questions to be asking. But I'm mostly curious about that Bermuda High position. I lose sleep over wondering where that thing is going to be sometimes. And so I look out there, knowing that this is the very, very beginning of the hurricane season, and just take note of a couple things. When you look at this map, the color coding is not temperature, it's pressure. So these would be higher than normal pressure anomalies, and these would be lower. Now, if you remember back to Phil's analog years, where was the Pacific High? Well, maybe it's centered here, but stronger there. And this goes out to July 22nd. Where's the Bermuda High? Is it shifted over toward the Azores and stronger here? Now, that is a question we're all trying to ultimately answer. And I'm going to come back to this map, zoomed in on the impacts in the near term on precipitation in the midsection of the United States. But I will tell you this, when you look back at his analog years, the precipitation patterns were not well established for June through August. I mean, just look at that. You have some climate reporting districts that were extremely dry, like in the Mid-South, and very wet in the northern parts of Mississippi and Alabama. Maybe it was an early onset to the southwest monsoon, but it's a checkerboard across the midsection of the country all the way to the east. And so understand that each of these years were also years like 2025, where the distribution of the precipitation was highly variable across geographies. One thing that was interesting, though, is that it did get warm. Most of those years were warmer than average for a big section of the U.S., maybe save the Northwest coast. And we do need some heat on this crop. I mean, we all know that if we look back, and this even includes the very warm days we've had. I mean, it was super hot in Nebraska and Iowa just lately. But you go back to mid-May, now through mid-June, and it's been quite cool here. We're behind on heat. We actually need that heat. Where's the heat been? We've talked about it. It's not in Florida, the Gulf Coast. It's been in the Southwest, which is continuing to crank with very, very high temperatures. Now, as I think this through, you all know that we are going to be seeing some better ridging that comes in the midsection of the country. And over the next 5 days, this heat that's been throughout the Great Basin through the Southwest is going to start to peel over into the Midwest. So as you watch, this is the next 5 days, and we're going out there day 5 through 10. Now, as this ridge opens, we have this evolution of a pattern that's going to start to generate more thunderstorm activity too, and the Northwest is going to start to cool off, right? And then this is this potential more tropical in nature thunderstorm activity that starts to push into southern Texas. But from southern Texas, like Austin, San Antonio, to Lubbock to Amarillo, major differences here in both precipitation and temperature going forward. This is now going out day 10 through 15. And what's interesting about the newest model evolution is this ridge, which some of the models, like the AI model, was trying to just plant and leave right here in the midsection of the country. And we've seen it change a bit. Could be due to the strength of the load that's going to be sitting over the Hudson. That could be part of it. But overall, we have watched the evolution of these models try to squash the permanence of the ridge. And so if you want to know what my personal assignment is this weekend, it's I want to watch for where that ridge is going to be in the model, each model run over the weekend to see how much of a change we get by Monday. So, all right, with all of that kind of set, I'm going to come back to the long range in a few minutes. We need to get back to where we are right now. If we just look at the radar from last night through this morning, again, look at the storms that came through parts of South Dakota and Nebraska. Watch this as it restarts. These are very interesting motion on these storms. See this guy right here? Watch it back build down this line, collide with this. Sorry, I had the mouse in the way, but huge storms. Just isolated, incredibly heavy rainfall and hail. While we had this low that moved out of Texas into Arkansas, Missouri, and it's going to spread widespread rain through this area today. Still more intense thunderstorms in the southeast as well. And as we just look at where this is going to be going, here's our next 7 days. Now, this has been the storyline we've had, right? So we understand we're opening Gulf. There's a pocket in through here that will likely be just a little drier than the spots surrounding it. We've noted that this area was drier, and there's this hard line right there where we are expecting to the west of it very limited chances of rainfall. The southwest, none. The northwest, I'll tell you more about some changes in temperature and precip here in just a few moments. But quite wet in through this area. And you can see this extends into pockets of the northeast. Now, if we just have a look at the severe storm threat, as we mentioned, Montana today. Watch this. All the way down this higher elevation just coming off the Rockies. Tomorrow, and then again here as we get out to day 3. So this would be Sunday. The suite of maps below this tell us where to watch out for the heaviest rainfall over the next 3 days as well. You can always go get these at agweather.com. I just linked to them straight from the Climate Prediction Center website, just so you can get a good glimpse at them. When you do that, come down here and run the high-res models too, and just have a close look at the timing on this. But the reality of this entire pattern is kind of set up here. It comes back to this narrative I've been trying to carry, which the Bermuda high, all right, pieces of it are here, but it's extending back over to there as well. And to the south of it are stronger winds and the trade winds coming through the Caribbean. Look at this, just pouring moisture into the low that we're going to watch today go through Missouri. But see this? There's also a trace of moisture that comes all the way here. And that is going to be critical for watching where the storms are going to be later on tonight. The Pacific high is anchored there, but it extends, all the way over to this region as well. And there's the circulation around the tropical system that we're expecting to form. Now, as you just look at this on the whole and just say, all right, show me the next week. Well, this is the chance of getting over an inch of rain in the next week in this particular pattern. And we can step it up to 2 inches. And there's going to be, this is going to be loaded with moisture. And we're recycling a lot of it out of the Mid-South, the Southeast. And so we're seeing very, very, high chances of very, very wet weather. And if you say, well, who's on the drier side of it? There's that line. See it? And it extends throughout much of the west. And as we just examine what this particular pattern, may do, I'm just going to come back to it. That Bermuda high position And we're going to focus a lot on the Pacific high again next week, though. That Bermuda high position is everything. So where is it? It's right here. Now, as I look at this, and you may be wondering the same thing, if you just watch this play again, okay, if we're getting all of this flow coming through this area, and it's just getting into here, why are we so dry in the forecast models in this area? I mean, if you just think about what that might mean as we watch this move forward, I got to answer that question. Why dry if you do expect to get moisture coming into this area? And is this carrying more of that Saharan dust over? Well, yeah, it is. You see here on the forecast for the next 10 days, according to the GEOS model, this is NASA's dust extinction. It's a optical thickness forecast. I mean, you can see that there is more Saharan dust getting brought over by those stronger trades. But I want to come back to this, right? We started here. We get this. This is all, I think, well accounted for in the forecast. But this is what we need to watch most carefully. And as I was thinking through what's going on there, I just think a lot about humidity, right? You can have enough moisture in the atmosphere to make storms, but if it's too hot, the relative humidity is your biggest problem. And I just I watch this. You can go out and look at these maps anytime you want, but you can just see humidity. I'm going back and forth in time. It's a map that flashes a lot because humidity is high at night and in the morning, and then it always drops in the afternoon and evenings unless you have a lot of cloud cover and precip. But I was just watching every day in the afternoon the humidity values here, relative humidity, and they're in the 30s, right? And so we're just questioning how hot is it going to get there? And as I just play it out, I'm curious. Like, I leave it back here. This is next Friday, and as you just examine this, Friday, I mean, humidity levels in 20%. So here's what's interesting about this. At that same time frame, if we just go out there and look at the temperatures, all right, watch the temperature start to just crank daily. Watch it now. It's all in the southwest now, but as we play this forward, we really start to see the heat returning to this area. I mean, just by Tuesday alone, 107, 93 in Amarillo. We just watch as we go through the remainder of that week. We get out there. I mean, that's that same Friday. We're looking at well into the 90s, 103 here. Very hot conditions. So the problem is, I went out and dropped a sounding there, is that you can get these really hot temperatures, and your humidity, your dew point is not, it's crazy low, but the difference is what makes the most important aspect of trying to forecast the storms. So we're not going to be able to just close the gap to give us a lower, what we call LCL, lifting condensation level, to pop storms. We don't get to use the instability. And so the net effect of that is just to see this drier area. And on top of that, over the next 10 days, our forecast models are bringing in repeated chances of very windy conditions in through here. So this is the feared scenario for the southern plains. Super wet spring. Now we start to see the temperatures coming in that are much hotter than normal. And the Gulf is opening up east, but we're not able to take advantage of it. And we're getting windier and hotter and drier in here, which means we're going to zap that moisture out in a hurry. And that is not the forecast I want to prepare, but that's the one that we need to be thinking about. Okay, so we've kind of bounced around a bit here, and we've looked at a couple of worrying spots, but here's that original narrative. Remember, all week long, what did we talk about? Ridge building in. It's going to start to build in this weekend. It gets here by middle and end of next week. There it is. While this trough drops into the northwest. There was the hope that we'd start to get this mega look to the pattern that would start to slow this down, giving us a better ability to forecast weeks 2 and weeks 3 and weeks 4. So it's not the hope in what the pattern's going to do. It's the hope that we'd be able to see out there farther. But as I play this forward, look at that trough digging into the northwest. Watch the ridge that is opening up here, through next week, by next Sunday, just get kind of squished a bit as that trough joins this Hudson low, which is something we need to think a bit harder about, that position of that Hudson trough going forward and what it might mean. And as we play it forward, that gets us all the way out there to the end of June. There's going to be a lot of unanswered questions, even in the week 2 forecast, because of the model spread and what's happening both upstream and downstream with the position of those high pressure cells, the Bermuda high and the Pacific high. So let's just take a look at week 2 and understand that I expect these to change a lot going forward. I take note of a few things. They all have this feature. We talked about that. They've all got a wetter stripe somewhere in through there. But there's some expanding dryness that's happening here. And it's only the GFS that tries to keep this area wetter. Both the AIFS and the ECMWF ensemble are a bit drier in the southeast. We need to watch this pattern carefully together to see how it's going to evolve. Now, we've jumped around between temperatures and precip and a story about hurricanes, but we'll ultimately need to bring this back to one thing. So the Climate Forecasting System Model version 2 gives us week 1, week 2, week 3, week 4 precip and temperatures. So real quick glance at them. Very similar to the narrative we just carried, right? See it? Wet, dry, wet, dry. If we look at the temperature pattern, okay, there's that ridge opening up. See the heat? Cooler, cooling off in the west. That comes back to that same thought process that while the west is going to get hot this summer, the long duration heat episodes don't yet seem to be fully in the cards. It's going to happen at some point, but I'm not overly convinced that the west is going to just see extremely long hot episodes going forward. What about week 3, week 4? See the pattern kind of become a bit less distinguishable, okay? And if you look out there on the temperature pattern, all right, the 27th through the 3rd, maybe some warmth here. I mean, warmth, when I say warmth, I'm talking about hotter than normal conditions. But you know what I'm mostly focused on? I'm going to come down here and just see where's the Bermuda high able to push its moisture. And I'll just say this. In the week 3, week 4 time period, I might zoom in there, we've kind of lost the stronger signal of the moisture push. And I don't know. Is the Bermuda high trying to go here? And the Pacific high way over there? And what about, week 4? Is it there? I think so. So I'm going to be questioning how easily we're able to keep that Gulf open as we get out here to the end of June and start the month of July. I think that's going to be a top thing to think about, because certainly the European model from June 21st all the way to July 21st, that would be the first full month of summer, it continues to paint this region drier. See it? Wetter east. It's also got North China Plain wet. It's got India wet with a continued active early start to the monsoon. It's got a lot of parts of Eastern Europe, Western Russia, Black Sea, drier as well. But if I had to distill this all down into one thing, okay, if we just come down to first principles of the fluid dynamics of the atmosphere, I'm going to leave you off with this idea. Remember how we talked about for the last several months, right? Look at this loss of momentum. It happened again briefly in the middle of May, and June's starting to see it again. And I'm just going to make a point here, all right? If we get another extended time period where through the mid-latitudes, which is here, we begin to see a loss of momentum in the northern hemisphere specifically, that is going to signal longer waves, that's going to signal more stagnant patterns, and that's going to continue to give us a 2025 growing season of highly variable precipitation. Now, what do I mean? I'm talking about in space, geography, places that are some spots are going to get wet and stay wet and not let go, while other places are going to get dry and stay dry. That's what low momentum in the flow does. And if you push the jet stream way up here, look, that's 60 degrees north. If that's where the fastest winds are, then we're going to be talking about a much different scenario for Canada than we are for the United States. So I've got my assignment for the weekend. I know what I need to be watching here, but that right there is something I warned on, right? We talked about the momentum building and then the momentum coming back down. And if it stays through here as we go into the month of July, that's just a bit of a dangerous overall setup in terms of trying to keep the atmosphere open and moving and staying away from precipitation extremes. So we'll watch it together, and I'll bring this back up again on Monday. Till then, you all have a good rest of your week and weekend. Be safe. We'll talk then. Thanks.